We have the pleasure to talk to another CEO of our 10x DNA portfolio. Paul is with me leading that area. We're talking about 3D printing. It's a very unique company and technology, but without further ado, tell us more about you, who you are, and which company you're leading.
So my name is Shai Terem, and I'm currently with Markforged, and we are based right outside of Boston in a city called Waltham, Massachusetts.
Perfect. So it's a 3D printing company. We're very excited about the space in general, but we looked into it, and there are many, many companies, but only a few are, we believe, attractive to invest in. So maybe give us a little bit more background about your company and what is unique about it.
Sure. So Markforged was founded about 10 years ago with the objective to bring industrial production to the point of need. When we started about 10 years ago, in the additive manufacturing world, there were a lot of plastic capabilities on the low end, a lot of prototyping, and a lot of metal capabilities, which were very expensive and very complex. What we tried to do is with advanced composites to replace the metal solutions in a very affordable, in a very easy to use manner. So we invented a technology which is called continuous fiber reinforcement that enables our customers to replace metal parts on the manufacturing floor very easy with advanced composites. And I think that's how it started. On top of it, I think another big differentiator of how we do our business is that we are a software-based company. All of the solution is on the cloud. We have many sensors inside the printers that collects data all the time. And we use all this data to ensure the solution gets better and better, gets more reliable, and even to higher levels of simulation, automated quality assurance, enterprise management, and others. But I would say software is a really important core of our solution.
Perfect.
Yes. Oh, yeah. Before we jump more into the technology, I would have one more question regarding the company culture, because I also used to live in Boston, in the Cambridge area, and I know it's a very dynamic environment. How is it to work as an engineer for Markforged?
So at Markforged, we have 6 core values that we try to live according to them. We see them as our DNA. This is how we interview people to join the company. Mm-hmm. This is how we manage the performance of our team members. And I hope that engineers like working here. The core values are, number one is one team. We work in collaboration here. So I think especially for our younger engineering team, the ability to make impact and work in collaboration is very, very important. The second is ownership. We are looking for our team members to take ownership on their successes, but also on their mistakes, not in a bad way, but in order to get better and learn from it. So we have a process around quarterly business reviews and debriefs to ensure that we learn from our mistakes. The third is don't stop believing. So we are really trying to change the future. We're really trying to change the way manufacturing is being done. It's hard. Sometimes it looks really, really far away, very, very tough, but that's a core value for us. The fourth is customer success. We are obsessed with customer success. It's all about our customer eventually and the part they need for the right cost in the right time. The fifth is around innovation. Okay, we aim to grow for innovation, to get more and more capabilities to our customers to change traditional manufacturing ways with additive manufacturing. And the last one is do great. We understand that we cannot do perfect. Mm-hmm. We're going to launch products. Our products are very smart. They collect a lot of data, and we're going to get better in time. So many of our customers that bought a solution from us, after a few quarters or a few years, the solution got better, which is phenomenal in capital equipment. So if you're an engineer, for us, I hope you enjoy collaboration because this is how we work. Again, we need to combine between hardware, software, and materials. It's not just one paradigm. It's all of them together. You need to go through hard challenges to don't stop believing that you can make it in the end. Always look for new stuff to invent. It's not about doing stuff that we've done before. It's all about the innovation. And I think you don't have the pressure to do something perfect tomorrow, because we do want it to get better over time. So from the notion with this flywheel that we have with all the data, the objective is to get the solution better and better. So I hope our engineers like to live through these values and invent new innovation through these values.
Understood. Let's continue with the part which also excites me the most, the technology, right? And maybe we can restart at the top and explain very briefly what is 3D printing and what's so special about the process Markforged is using.
Sure. So maybe I'll start by talking a bit about what is traditional manufacturing, which is mainly subtractive. Okay?
Yes.
Traditional manufacturing, you take a piece of metal or wood or whatever it is, and you carve into it with usually CNC machines or with drills or with cutting tools, and you're basically trying to take the pieces out of the bulk of materials that you don't need. And eventually you end up with the part that you're looking for. In additive manufacturing, it's exactly the opposite. You build a part layer by layer until you have the final part, but you build it usually only what you need. So you eliminate a lot of waste around it. So I think when you're looking on additive in general, okay, it's trying to eliminate a lot of the waste that happens in traditional manufacturing. Usually, once the design has been done on CAD software, you can import it very easily into a printer that just press print. So you don't need the mechanical skills to work with the CNC machine. Okay, you don't need it, just press print, right? And I think when you look even to the higher levels, you can move into what we are all looking for in automation of industrial automation and digitization, because you can put inventory and replacement parts on the cloud. You don't need physical inventory, and then you can build them when you need them in the point of need. And there's a lot of saving there around cost, space, but also a lot of carbon emission. If you think about it, if you can move to production at the point of need, and you don't need to ship stuff, fly them, truck them, it's a lot of carbon emission which is saved to be used only when you actually need a part.
And what I really like about it is that it's basically you can evolve. As you just mentioned, you are a software company. So if the part, can be designed in a better way because you learned in the field that something in very extreme situations break, and you have an idea like how you can do it better, you can do it in real time. The next part that will be produced from the cloud will be updated. So there are many advantages in this kind of creation.
Correct. It's also the time, meaning we can iterate much faster when you go through innovation cycles. Okay, if you are trying to develop a new product and you need to build prototypes and you need to wait for parts that will come from a machine shop, it will take a few weeks. If you have a 3D printer, tomorrow morning you're going to have the part. And then you want to do some testing and iterate it, you change it faster. Tomorrow morning, you have another part. And it's accelerate the innovation cycle, okay? And as you said, with additive, you can do stuff that you cannot do with subtractive manufacturing. Because in subtractive, it's only straight lines, usually. It's a drill or a cutter, but you can do only straight lines. In additive, I can build structure that you cannot machine. So there's a lot of stuff, a lot of parts with additive that can reduce the weight, but keep the strength, okay? Be produced with materials which are very tough to machine, like copper, for example, okay? There's a lot of advantages that additive can solve and traditional manufacturing cannot.
Definitely. We also have these in our market hypothesis, right? That we definitely believe in this big advantage, also like the complex geometries you can design and also create with 3D printing. But maybe to start, or like as a starting point, it makes sense to start with the process, right? And I think here it would be super nice to get like an introduction from you about like fused filament fabrication. How is it working and what machines Markforged has on the market in this area?
Sure. So for the core technology which we have, which is an extrusion-based technology, or in the previous name it's called FDM, fusion deposition modeling. I think the best analogy for it is a glue gun. Okay, you take the glue stick, right? You push it through the gun with some pressure. It's getting hot, and then you can put the hot glue wherever you want and create something with it. So we do it very, very fast and very, very accurate. Our printers have extruders, more than one, and we push filament through the extruder, heating it to a level that is really meshing, and we put it in the right place, and then we build the part layer by layer. We took it to the next level, and we don't have just one extruder, so we have a few, and we can print also what's called continuous fiber reinforcement. Our core material, called onyx, is a combination of PLA 6 and nylon 6 and chopped carbon fiber. But we have another material which is continuous fiber, and we have carbon, we have Kevlar, HSTC, and others. And basically what we can do is to print with the onyx material, which is like cement in construction, but can also put into it the continuous fiber reinforcement, which is like rebars when you do the construction. And when you put the two of them together, you have something which is stronger than aluminum. And I think that's a big advantage in our technology, in the core technology around the continuous fiber reinforcement.
Definitely, yes. And I think like one other aspect is also the weight, right? So if you compare to metal parts, can you give like an example so that you get a feeling for it, basically?
Right. So when you move to advanced composites, there's a few advantages. One, it's lighter than metals. Okay, advanced composites are lighter than metals. Second, they are cheaper. Okay, usually when you move from a machine part to advanced composite printed part, it's almost 1/10 of the cost. So it's significantly cheaper. It's much easier to fabricate. Okay, so dealing with metal, carving, drilling, it's tough. You need to special machines. In advanced composites, it's much easier to fabricate new solutions. You don't have aluminum fatigue. Okay, if you put a lot of pressure on a metal part, eventually it will deform, right? It will change. In advanced composite, they always come back to how they were. Okay, There's no corrosion. Okay, in advanced composite, there's no corrosion like you have in metals. There's no rust. So when you look about replacing metal parts with advanced composites, there's a lot of advantages. And again, we did not invent advanced composite. In the last 20, 30 years, especially aerospace and defense has been adopting a lot of advanced composites parts. It's going more and more into electric vehicles and others. But in the additive manufacturing space, we are the leaders in advanced composites.
Yes. And what would be like typical use cases of this?
So I would say our number one application is to be the best tool to the manufacturing floor. We can replace many, many parts, jigs, fixtures, tools, soft jaws, whatever you need on the manufacturing floor that used to be metal parts. We can replace them with composites or with a combination of composites and metal. We can also print metals. The second segment for us is a lot of machine builders. Okay, for example, automated packaging. Okay, when you build a machine which is dedicated for a specific box, and you have 10 of these machines, okay, or 20 or even 100, it's still low volume. Whenever you have low volume, high value solution, it's a great application for Markforged. We can replace a lot of parts there to be cheaper, to be stronger, less maintenance. You can trust them. You can make sure that they are printed at the point of need, okay? And the last application, which we are starting to touch, is what we call mission critical applications. We do have some parts that going into aircrafts. We have parts that going into cars. So we are going more and more into applications that if, God forbid, it breaks, something really, really bad happens. And this is where we have, again, the advantage with our solution.
Yes. Let's stick to the polymer and composite parts, right? You have a very broad portfolio of printers. Maybe you can guide us through, like, from the smallest ones to, like, your newest, biggest machines.
Sure. So we currently have about 4 platforms, more or less. The smallest one is around the Mark II. The Mark II is a desktop solution that can print, again, chopped carbon fiber, the onyx, but also continuous fibers. The parts are usually what we call shoebox size. Which is great because 80% of the parts on the manufacturing floor are shoebox size. And this printer is very, very reliable and very, very affordable. So we have customers that replace with the Mark II solution $1,000 metal parts with advanced composites parts. So the ROI is very fast. It's usually 3 to 6 months the customer can find ROI. After that, we have a platform called the X7. X7 is bigger, faster, also have laser inside that can scan the part while it's being printed. So we have a level of automated quality assurance on the part. So if you are printing parts from a digital cloud, you can ensure with our capabilities that you have exactly the same parts if you printed it here in Boston or you printed it in Germany. It's exactly the same part, wherever you printed it, okay? And this is a higher grade industrial solution. So we can print bigger parts or much faster, smaller parts. Bigger than that, we have the FX20. It's one of our newest platforms. And the FX20 is significantly bigger, so we can print 2 feet long parts sometimes, significantly faster, so it's going to high volume production. We have customers that used to take over about 6 hours to print part on X7. Now it's 1 hour. That's a huge element of productivity of the solution. And in addition, it can do high temp materials. We have a hot chamber there, and you can print high temp materials like Ultem and other materials that we are working on. And these materials, we can also put, again, the continuous fiber reinforcement in them. So now we're talking not just about advanced composites part, but also about advanced composite part that can resist very high temperature, up to 200 Celsius sometimes, and don't deform. And they are stronger than aluminum because you put the continuous fiber inside, okay? We have another solution called the Metal X. The Metal X can print metal parts, D2 steel, 17.4 copper, Inconel 625, and other. It's extrusion-based technology. It's very safe metal production, okay? Because we produce the filament, there's no loose metal powder, so there's no risk of explosion. You can put it anywhere you want. A lot of success in the education field with it, and it's very, very affordable. Only 3 stages. You print a part, you wash it, and then you sinter it. This is the Metal X. And the last solution, it's called binder jetting. Binder jetting is a new technology. Instead of having one extruder that basically print one point at a time, we have a printhead that has about 70,000 nozzles. Each one of these nozzles is shooting binder, glue, on metal powder and building it layer by layer on a full A3 page. So it's a much faster technology. It can print very high volumes into mass production of metal parts. So these are the platforms that we have.
So what I found very interesting in your industry is when exactly are we switching from all the advantages of the parts that we discussed to the mass production, so that more mass production facilities will use 3D printing and switch. How do you see the current situation in the market of your product? So when will we see more mass production with 3D printing?
So I would say on the polymer side, on the plastic side, we are still far away. I think the technologies we have today cannot compete on the cost per part with injection molding. So if you really need millions of parts which are the same and they need to be very strong from isotropic perspective, injection molding is still the cheapest way to do it. But sometimes supply chains are broken and you cannot get the part, right?
Yeah.
Happened in the last 2 years a few times, right?
Yeah.
So when we go into these cases, building resiliency to a manufacturing floor, to the supply chain, and having the ability to print the parts on hand when the supply chain is broken, is it more expensive than injection molding? Yes, it is. But it's the only way to get the part. It's the only way to ship the car. Because without this, you cannot ship the car.
And that's really expensive. If I have to stop and cannot ship and the customer is annoyed or I cancel an order, that's really, really expensive. So it doesn't matter what the one part, it might be a little bit more expensive.
Exactly.
But you can deliver. Yeah.
Exactly. So I don't think we're going to see a polymer printing of millions of parts. We are far away from it from functionality perspective, but in the thousands, we're already there. Mm-hmm. On the metal side, okay, I think binder jetting is really pushing the limits now on this one. I think with binder jetting, you can produce hundreds or thousands of parts, depends on the size, in the same print, and you can start actually replacing and competing on the cost per part with metal injection molding or even metal stamping, depends on the complexity of the part. So I think in binder jetting, we're in the beginning of high volume production of metal parts on an additive way. But in general, I think we are still a few years away, meaning additive manufacturing still have the best advantage in high value parts with low volume production. That's the biggest advantage today. Or production at the point of need. Meaning, if you are trying to build resiliency, overcome supply chain challenges, or deliberately move to production at the point of need. Think about printing the part at the car dealership. Think about printing the parts at the airport. That's a huge advantage that additive can do and traditional just cannot do.
For sure. You already talked about the advantages of binder jetting, right? The very high process speed, but it also has some challenges yet, right? Talking about post-processing and also the binder on its own. What would you say are the biggest challenges and how will they overcome in the upcoming years?
Yeah, I would say binder jetting in metal is still a fairly new technology. If you look on some of the research report out there, the assessment it is somewhere between $50 to $100 million. So it's a relatively new technology. And as such, the stability, the reliability, repeatability of the solution is not in the levels of powder bed fusion, for example, which is out there for about 40 years, right? So I think these are the challenges a little bit. The process is a little bit more complex. As you said, you need to pre-process the powder, you need to post-process the part to take the powder out of it, you need to cure it, then you need to sinter it. The process is a little bit more cumbersome, but with our solution, for example, you can get to very high level of accuracy with our parts, very small standard deviation, so you get repeatability to a level which, for example, with our binder jetting solution, one of our customers was able to certify the PIPA process for automotive, to print parts in high volume production for automotive, and you don't need to do machining after, meaning it's accurate to the level that you have all the right tuning that you don't need to do machining after. So yes, we're in the beginning, but it's very, very interesting the pace that it's growing.
Yes, for sure. We talked a lot about the hardware, but as you already said at the beginning, software is also like a very big part of your business. Taking a look at the software, I think we can split it up maybe in the connectivity software and also in like the simulation and inspection part. Starting with the connectivity software, what value does it bring your customers?
Sure, that is a great question. So Markforged today has over, I think, 14,000 connected active printers. Okay? Over 14,000 connected active printers that we collect data from them all the time. And we are using this data to ensure the solution is very reliable. For example, if we identified a bug in one corner of the world, we could fix it in your printer and you don't even know it, which prevents you from even getting this bug. Okay? For example, we can fix or overcome mechanical challenges or chemical challenges with software. Okay? For example, we were able, if you bought an X7 from us in the beginning, 2017, 2 years after, through a software update, you could double the productivity. Think about it. When is the last time you bought capital equipment or a car that 2 years after the software update, you can drive twice the speed? It never happened. All of this is being enabled with software. I think the best analogy here is like autonomous driving. The more people drive with autonomous driving, the more data goes into the AI system, the machine learning, and it creates a better experience. People get more confident. They drive more mileage, more data, it gets better. The same with our solution. The more people print with our solution, the more data we have. The more data we have, the solution gets better. Solution gets better, you can answer more application, people print more. And this is this flywheel that increases the utilization of our solution. So that's on the connectivity side. So I think on the software side, we're trying to push the envelope and try to automate more and more manual processes. For example, with blacksmith, we can do a level of automated quality assurance. So instead of scanning the part after, our solution is already scanning with laser the part layer by layer and tell you in the end if you got exactly the same part, yes or no. Okay? With simulation, we can reduce the amount of iteration, the physical iterations when you develop a new product and do simulation of how strong the part will be. And to do simulation to productivity for speed optimization, cost optimization, and the strength optimization. So with simulation, we are helping our customer to move to the next level of real production of parts. Okay? Another capability is around enterprise, the ability to manage a solution remotely. Okay? To understand who has access to which file, who can change files, etc. So this really gives our customers the ability to work globally with our solution. And the most important thing is security. Because all of the solutions on the cloud, we need our customers to trust us that when they put their most precious asset, which is the IP, on our cloud, it will be secured and it will not go to their competitors. And this is why we are, I think, the only company in the space that have ISO 27001 for the security, which is very, very important for our customers.
Yeah. No, definitely. And I think like in the last quarterly reports, they say like 90% basically of your printers are connected in the cloud, right?
Correct. We still have some percentage of, I would say, defense customers and other very unique customers that deliberately want to stay off ground. They are connected once in a while to get all the updates, but on a day-to-day, they are not connected. About 90% plus are connected all the time.
Mm-hmm. Yeah, we also think like one of the key challenges still for 3D printing is like the usability, right? So if you have like a very complicated software, or if you would have one, it's hard for the customers. How does basically your setup with like the simulation, inspection, and so on help customers to make 3D printing easier for them?
That's a really good point. So I think if you think in general about what's preventing additive manufacturing to get to the next level is adoption. Adoption is tough.
Yeah.
And adoption is tough because technology is new. You need to build the trust, but also to use it is tough. What we try to do with software is to make it really easy to use. Okay, so for example, with our solution, my kids, which are about 10 years old, can print parts in our home. So think about it. I have a 10-year-old kid printing advanced composite parts in my home that can replace metal parts. It's insane, but it's already happening.
Yeah.
Okay. Now, with the tools that we're adding, we're making it even easier. Okay. So, for example, instead of an FEA simulation tool that costs about $50,000 per seat, and you need to be a professional in using this simulation tool, with our simulation, you get a drop-down menu. Okay, you get a drop-down menu and you can choose, okay, I want to optimize for speed, I want to optimize for cost, and it gives you all the option immediately. Now, of course, it's not in the level of an FEA simulation, but you don't need to do FEA simulation to every part. So we are really simplifying, okay, the usage, but giving the capabilities to our customers. Okay, think about quality assurance. You don't need to scan the part after. You don't need to. Okay, the software is doing it for you. And you don't have to do anything. You just press in the beginning. Yep, backsmith, done. Okay, you're gonna get green if it's already.
So you are in a high growth market, and many production companies will change towards 3D printing. You as a CEO of the company, what are your challenges to growth? So what is holding you back? You have the software, you have a unique technology. It's easy to implement. There's a very fast time until I got my capital back when I invest. So what are the things that you work on daily that say that's what we need for even growing faster?
So probably won't be a surprise, but the toughest thing as a CEO is to say no, right? Because there's a lot of innovation that we want to do.
Yeah.
But we need to focus. We are razor-sharp focused on getting to profitable growth. So it's not just about growing. It's about also building sustainable profitability into the organization. So the biggest challenge is balancing between the investment into the future versus hitting the profitability. Because we continue to grow in the revenue, but I always have more R&D that I want to do. So when and how to balance the investment from R&D that's going to be the future growth engine, okay, versus building the profitability. That's kind of the biggest challenge, I would say, as we are growing, to grow, but get to profitability and not keep the growth to the side of it. Like, we continue to bring new innovation all the time. We invested over the last 2 years over $100 million in R&D, organically and inorganically. And of course, we expect that we're going to have very positive ROI on this investment over the next few years. So, for example, binder jetting is a new solution that came inorganically. FX20 is a new solution that came organically. And as we said publicly, this year is a very exciting year for us, because in the second half of this year, there's more technologies and more innovation that we are about to launch. We worked on them behind the the scenes for the last 2+ years. And with all of this new innovation, with all of this new platform, we expect to have kind of accelerated growth in the upcoming years.
Talking about the hardware and the software part, how do you see the split in the future evolving? Because software has such a big value. And if you look at Tesla, for example, coming from producing cars and now hopefully being able with FSD to become more software company, how do you see this hardware software part in your company?
I think it's a tough combination, but we are talking about the physical world. Okay, eventually we want to replace physical parts that goes into a car that someone actually drives. Okay, as such, it's more complex, but a required combination. I think doing just hardware, which is dumb and can print a part, is very limited, and there's no big future there. But enabling our customers to really move to digitization of industrial production, okay, into really move into industrial production at the point of need, using software capabilities to eliminate all the manual efforts that you need to do around qualification, around automation, whatever is needed. Okay, it's a must for us as we evolve in this world, and we get better solution with software. Okay, for example, with our engine, with all the data that we have, each FX20 collects terabytes of data, terabytes. Okay, so think about the level of quality assurance I can give to an aerospace company. We know exactly what happens layer by layer when we build the part. It's much better and much stronger than just get the part eventually and scan it from the outside. So I think software is key to the success of our industry. It's key to the success of Markforged, and it's really enabling us to increase the quality of the solution, the reliability of the solution, and eventually the adoption of the solution.
Mm-hmm. So, yeah, maybe switching again to the markets. As an example, here in Germany, we also have a lot of strong, small and medium-sized companies. What is basically Markforged value proposition for these companies? Why would a company choose Markforged instead of like other competitors?
I would say each one of these small companies is limited from resources to build all their solution on their own. So they use subcontractors. Mm-hmm. So they have a machine shop probably that produce for them some parts. They buy other tools from someone else. They don't have the resources and the money to do everything in-house, because they're a small business. I think with Markforged, depends on the size of the business, what you need. You can put a solution in-house that will reduce the cost materially to buying all of these parts, tools, jigs, fixtures, whatever, from another contractor. Give them the control on designing this part to be customized and optimized to their specific problem. Giving them the advantage of reducing inventory and manage parts digitally and print them only when you need them. Okay? Mm-hmm. And yes, giving them the advantage of attracting talent, especially new talent of engineers that are looking for additive versus subtract. It's very tough to get CNC machinery today. Like, yes, just people don't want to do it. Okay, but printing additive is cool, and a lot of people. So actually, we have a few customers in Germany that I went to see, and they moved materially their production from traditional to additive. And by now they have 10, 12 of our printers printing 24/7 parts that historically used to be machined. But they cannot find machinists anymore to do the machining.
Crazy.
Mm-hmm. Yeah.
Okay, so these are huge advantages, especially for small businesses, which are limited from resources. So you start small, you can start with a desktop printer, but even our small printer, the Mark II, can print parts which are stronger than metals in a very easy way. You don't need to be a PhD in physics to print with our solution. Okay, if you have the design, you press print, the system will do everything for you.
Yeah, and everything comes together because also designing the parts, there's so many great ways from AI to the tooling, and then just printed it. So yeah, so many advantages has come here together, and then how easy it is to start. So we are really excited about this.
So, Shai, there's a lot of stuff going on in the 3D printing world on a big picture at the moment from a market perspective, right? So I think who follows this industry, there's a lot of going on with like the offers from Stratasys to acquire Desktop Metal, and then also the offers from like Nano Dimension and also 3 Systems to merge with Stratasys. With this consolidation going on, what's the impact on Markforged?
Oh, it's actually good. We can focus on execution. So look, we were very fortunate to secure a very strong balance sheet about 2 years ago. And we publicly said we're going to invest a lot into new innovation that will accelerate our growth. And for the last 2 years, we worked really, really hard behind the scenes, despite many challenges, despite the inflation and yes or no recession. We continue to invest in R&D, and we are very fortunate that by the end of this year, we're going to have many new products out there. New products mean new capabilities that our customer can do and they can grow with. We developed a strong brand around reliability, around repeatability, around security, and this is how we win on the manufacturing floor. And we are focusing on execution. And when others are thinking yes or no, they have a job, yes or no, you will have a support from a company if you buy their product, yes or no, Markforged is here, it's here to stay, and it's here to support our customers in the best way into the future. So this is what we are focusing on, and I think we're on the right path.
Talking a bit about the future of the 3D printing market, I think there are, as Frank already said, plenty of possibilities also, like using the best word AI, but like when we talk about parametric or also generative design of parts. What's your view on this development, basically?
A, I think it's coming and it's a must because I think that will be a great tool to accelerate design. And B, I think in order to get a good outcome, you need a lot of data. And you need a closed loop system to know what's happening after you print the part you should design. Guess who has all this data, and guess who has the closed system that knows exactly what's being printed? Markforged. So I think it's coming. I think it's part of the future, and for a very I would say we are deliberately investing a lot in being a software-oriented solution, collecting all this data for many years now and using it to get the solution better. I think generative AI will take it to the next level. And again, we are sitting on 14,000 connected printers and all the data of how a part been printed and what you have in the end and the simulation. So It's definitely the next wave in additive, no doubt.
Okay. Last question from my side. How will Markforged look like in 10 years from now?
So if you think about Markforged, okay, we're not just a 3D printer company. We are really trying to bring industrial production to the point of need. Each one of our solutions, which we call the Digital Forge, is a platform of hardware, software, and materials working together remotely. You don't need a human there, okay? Secured, trusted for high kind of mission critical applications, okay? And they can really replace metal parts wherever you need them. My hope is that in 10 years, you're going to see a Markforged in many more thousands of manufacturing floor, okay? And not only on the manufacturing floor, okay? I want to see Markforged solution on a car dealership. I want to see Markforged solution in an airport. I want to see Markforged solution, I know, in the International Space Station, wherever you can or you need to build industrial grade parts, we need to be there. We can be there and provide value to our customers.
Shai, thank you so much for joining us today. It was a great CEO interview. So we now have a deeper understanding about Markforged. We at 10x DNA are happy shareholders and we're looking forward to this partnership and what's ahead. So we don't know what's ahead. So you will announce some new products. We are excited and really want to see what's coming. And thanks for your time today.
Thank you so much and appreciate the partnership.